Hi everybody, this is Mrs. Ellsworth, and what we will be talking about in this video is two problems from homework 5-6 concave mirror problems. And what we're going to be doing is we're going to be using ray diagrams to use those properties of reflection to help us determine where the image will be located at, and also to do some of the math to help support that evidence. So the very first problem that we have, again, this homework sheet 5-6, okay, it says find the image distance and the magnification of the mirror with a focal length of 10 centimeters when the object is placed at 5 centimeters from the mirror. Okay, this is distance of the object. Okay, and so to continue reading here, find the DI, and find the DI, that's what we're going to be looking for, is the distance of the image and also the magnification. Okay, also tell me whether this is real and inverted or if it is a virtual image that is upright. So we're going to draw that ray diagram to help confirm it. So let's go ahead and get started. We'll go ahead and place our object. Okay, so it says that the focal point is at 10 centimeters. So then we will go ahead and draw our object right here in the middle at 5 centimeters. And I'm going to be estimating mine. And you can draw along on your sheet too. You may have to draw this curved mirror. Try and be as symmetrical as possible so that your drawing can be somewhat accurate. Anyway, so our very first part of this is to draw our object. So I'll go ahead and draw my object right here. Okay, and I'm trying to go straight upright, and I'm not doing too well. So there's my object right there. It is placed in front of the mirror, and it is about halfway between there. So I know that it's halfway between the focal length and the mirror. And so I'm going to go ahead and draw my lines. So do you remember what the first line is? The first line is it goes to the mirror, and then it doubles back and goes to the focal point. Okay. The second line that we draw, if you remember right, it goes from the tip of the image to the focal point. Wow, look at that. These are diverging. That means that the image is converging over here somewhere. So let's think about that. How can we use these lines here to go and extend them so that they will help us solve this problem? And so we talked about this briefly also before when we were talking about when we draw these, when the object is placed between the mirror and the focal point, we have some neat things that are happening. Okay, and so we'll go ahead and let me draw these ones. The second one, remember, it goes, this one has got that specific thing where it goes through the focal point, and but then it's going to go horizontal after it hits the mirror. Normally it goes horizontal, but anyway, so we'll go ahead and continue with that. Wow, I see that the image is probably going to be right here. Remember, it is usually a virtual and upright mirror if it's between the focal point and the mirror. And so let's go ahead and do one last line, just double check that information. Okay, and so here from the center or the radius of the mirror, we'll go ahead. Oh wow, that lined up pretty dang nice. So it's right on top of here, it goes through the C, and so that is with our instructions. So it looks like our image is going to be right here. Okay, that's not too far off here. Well, let's see what we can get for some calculations. So I went and grabbed these formulas here from our ray diagram sheet that I gave you to use on all of this type of homework. And so it's got this formula here, but we have the focal length. And we also have where the object is, the distance of the object, but we do not have this one. So let's manipulate this so that we can solve this one. So I'm going to draw that down here. So I've got, okay. So what we have to do is we have to subtract this one from both sides. So this is going to equal 1 over the focal length minus 1 over the distance of the object. Okay, so let me get that here for us. Okay, so 1 over 10, because the focal length is placed at 10. If you remember that right, that this is the positive side of the mirror and this is the negative side of the mirror. So that'll be interesting to see what happens there. So the focal length is placed at 10, so we'll put 1 over 10. Okay, and the object was placed at 5 centimeters, so it's 1 over 5. Okay, so when you do these, go and plug them into your calculator, and remember that this is 1 over di. So the calculations here can be a little bit difficult, so let's go and work through them. So I'll go plug these both into my calculator, and then I'll get a decimal value for it. So go ahead and do that. Catch up with me. Try this. Let's see what you get in your calculator. Okay, pause it and check it out, but let's go ahead and finish this up. So notice that when you put this in your calculator, you know, this is 1/10 minus 2/10 here, and so you're going to get a negative 1/10. So remember, that is 1 over di equals 1/10. I mean, right here you can see, oh, negative 1/10. You can see that di is going to equal negative 10. But what do you do if it's not a pretty number like that? Well, you would just go and take the negative 0.1 in this case, and then you would go and press the reciprocal button on your calculator, which is an x to the negative 1 on our blue calculators, and is a 1 over x on our yellow calculators. Press that and you're going to get a negative 10. And that is the distance that your image is from here. It's on the negative side of the thing, and it should be 10 here. It should be equal distance here, but it's not, unfortunately. And so, but your drawing does help support that this is located somewhere near that, isn't it? So the distance of our image, so we found that one is di, okay, and that one equals a negative 10 centimeters. Okay, so that's one of our answers. The other one we had to find was magnification. So let me find that formula for you. Okay, so on our ray diagram worksheet, I guess that this right here isn't a worksheet, it's our problems formula sheet and telling you how to do the ray diagrams. Anyway, there is this formula here on the back side. To find the magnification of the mirror, you could go and take the height of the image divided by the height of the object, but if you're not given those heights right there, then you can't use that part. Most of our problems will be using this negative di over do, and I forget that negative, so whenever I write out this one, I write it out like this. Okay, magnification equals negative di all over do. Okay, and we just calculated both of these, and so our distance of our image is actually a negative with a negative 10 centimeters. Okay, centimeters are going to cancel out because the distance of the object is also centimeters too. Okay, and that is over 5 centimeters. So that's pretty cool. Our magnification is 2. The centimeters will cancel out on both of them. And this is telling us that the object is 2 times the height of the original object, because this magnification, this mirror, is 2 when it's placed right here. That's pretty cool. And so obviously our drawing is not perfect, but it does help support that it is quite a bit larger, not 2 times as large, but it's pretty nice. Okay, so I'm going to stop this video here. Okay, see you later.